The last section we'll talk about involving gases is real gases, which introduce deviations from ideal behavior. And the ideal gas law uses some assumptions from kinetic molecular theory. And those two assumptions are that the volume of a gas is negligible and that intermolecular forces of attraction are also negligible. And in the ideal gas equation, we actually assume that each of these are zero. So if the ideal gas law held true for all gases, we would know that R is equal to PV over NT, and this R value is equal to 0.08206 liter atmospheres per mole Kelvin. And this would be true for all gases, but it's really not the case. So we need some kind of modification or correction to be applied to this to correct for this volume and intermolecular forces. So a guy by the name of Johann van der Waal introduced two correction terms to describe the behavior of real gases. And it's very similar to the PV equals nRT expression, but instead for the pressure, we need to add a correction term, which is P plus N squared A divided by V squared times V minus N times B equals nRT. And this first term right here is the correction term for intermolecular forces, and this term right here is our correction term for the volume. And if A and B are zero, then the ideal gas law would be obeyed. So if A equals 0 and B equals 0, this equation here simplifies to PV equals nRT. So if you have a large value of A and a large value of B, we're going to deviate from ideal behavior. So if you look in your textbook on page 412, which is table 10.3, that lists all the A and the B constants for common gases. And we can actually calculate then the pressure and the volume for these real gases using this van der Waal equation that we have listed here.